Welcome dear students. Today our topic of deliberation is milling systems. In this chapter, we will be studying about the milling of cereals. The major objectives of today's deliberation are: number first, to understand the milling of paddy to produce rice. Number second, to understand the traditional milling methods of rice milling. Number third, to understand the modern rice milling technology. Number fourth, to understand the process of paddy harvesting, threshing and handling. Number fifth, to understand the modern milling control technologies. Milling is an ancient art. Its objective is to make cereals more palatable and thus more desirable as food. Paddy or rice is an annual grass which can be grown under a broad range of climatic conditions, mainly as a semi-aquatic crop. Cultivated rice is either Oryza sativa L or Oryza glabrima. Oryza sativa is the predominant species. Oryza glabrima is grown only in Africa on a limited scale. In Asian countries, 80 to 90% of population is mainly dependent on rice as their staple diet. Rice is consumed in many ways in various countries. In addition to cooked rice, it is also consumed in the form of rotis, noodles, puffed rice, beaten rice, breakfast cereals, dosa, idli, etc., rice cakes, fermented and unfermented sweet rice, and snack foods made by extrusion cooking. Rice is also used in making beer, wine, and vinegar. In most Asiatic countries, rice is consumed in the cooked form and are normally served with vegetable or non-vegetarian curries, soups. There are many kinds of snack foods prepared for more attractive taste, texture, and aroma. They are mainly served in special occasions for some special tastes and for convenience. Some rice snack foods are made from either sticky or glutinous rice, sweet or waxy rice, containing largely amylopectin, 98% of total starch, but very little amylose, less than 2% of total starch, while others are made from both types. A typical glutinous rice flour contains 11 to 13.5% moisture, 1% ash, 75 to 80% total starch, 5.5 to 6.5% protein, and 0.5% total fat. Glutinous rice flour is often used in making snack foods, since the sticky characteristics of high amylopectin content are necessary in many, especially rice foods. Another reason for application of glutinous rice in baked and popped snacks is that it expands readily and produces a more porous texture. Paddy harvesting, threshing and handling. Paddy is harvested from the fields and thrashed to separate the straw from the grains. The grains are then transported to the mills for further processing. Paddy received in the mill generally contains moisture higher than that is safe for storage and hence needs to be dried. Moisture content of 18 to 25% is normally present in freshly harvested paddy. Moisture content of below 14% is considered safe for short periods of storage. For longer storage, the grain should be dried to 13% moisture or less. Drying process may be either through heat supplied, by hot air, or by the sun drying, where the moisture from the grain evaporates while the moving air carries away the evaporated moisture. Paddy received in the mill must be first cleaned to remove the foreign matters before it can be properly stored. The foreign matter may be other plant, weed seeds, straw, chaff, sand, stones, dust and pieces of mud and iron particles. If the paddy is not clean, they may cause deterioration of paddy during storage or may damage or obstruct the conveyors and milling machinery. Cleaning also helps to reduce storage space. The first cleaning operation of paddy after threshing is called scalping. In this process, based on the density of the particles, they are separated. Milling of rice. Rice is mostly consumed as cooked whole grain, unlike other food grains. Milling technology aims to obtain maximum amount of milled rice outturn. Thus, milling is designed to reduce breakage. Rice milling systems range from the home scale to the large, complex modern rice processing installations. Paddy milling from home scale includes hand pounding equipment to village level hullers. They may be single hullers, battery of hullers, emery shell cum huller mills, emery sheller cum cone polisher mills, and the modern rubber roller rice mills. The single huller mills are located at village levels or in localities where paddy is milled based on the customer requirements. The quantities are normally small and are milled to the requirements of the customers who bring the paddy and takes back rice for their own captive consumption. Hence, the capacity of these mills ranges from 250 to 750 kg per hour, and they still handle the bulk of our country's production. The large capacity rice mills located in urban or semi-urban areas for commercial milling are of 1.5 to 4 tons per hour capacity, where the paddy milling is normally carried out for commercial requirements. Traditional rice milling machinery. Traditional rice mills include hand-pounding equipments, single huller and battery of hullers, sheller cum huller and sheller mills. Hand-pounding. A variety of implements are used for the purpose of hand pounding, the more common being A. mortar and pestle, B. dinky, and C. handstone chakki. Huller mill. The huller mill combines both dehusking and polishing process in one operation. Therefore, the byproducts, husk and bran, are mixed together. The average milled rice recovery in the case of raw rice is low, up to 65%. Or less. Breakage is high. Besides, it requires high power requirements per ton of paddy milled than other type of rice mills. Battery of hullers. These mills consist of a battery of hullers. In addition, sieves for cleaning the paddy, reciprocating sieves for removing broken, aspirator to remove the husk, and bran etc. are added. The hullers work as parallel units to increase the capacity. As yield from huller is poor with raw paddy, these commercial mills are mostly found in areas where parboiled rice is eaten. Sheller cum huller mill. A disc sheller, emery sheller, emery dehusker is used for dehusking, and the huller is used for polishing the dehusked brown rice. After cleaning paddy in a sieve, the clean paddy is dehusked in a disc sheller and the husk is aspirated. The stalk from the sheller is fed to hullers for polishing, often with a screen-type paddy separator in between. The mixture is then sifted and aspirated to remove bran and small brokens from head rice. The outrun of rice from this mill is higher by 1 to 2% over the huller mill for raw paddy. Sheller cum cone polisher mill. The disc sheller cum cone polisher mill consists of a cleaner, disc sheller, aspirator to remove husk, paddy separator. This mill gives more outrun of rice than hullers by at least 3% for raw rice. In addition, the head rice yield is higher, breakage is reduced, bran and husk are separated, the rice is clean and free from paddy, and the degree of polishing can be easily controlled. Small capacity rice mills. Paddy produced in Asian countries is still largely consumed by the farmers themselves. For this reason, there is still heavy demand in Asia for small capacity mill where small quantities of rice can be milled. Engelberg Huller. The Engelberg Huller is the most widely used for a small capacity rice mill. The Huller consists of an iron-ribbed cylinder mounted on a rotating shaft and fitted in a cylindrical housing. The bottom half of housing is fitted with a slotted sheet. It combines the dehusking and polishing processes into one operation. Modern rice milling. Modern rice mill means efficient rice mill, a paddy receiving, cleaning, drying section, huge godowns or silos, parboiling drying system, a huge husk furnace, cum boiler, ash handling section, bran handling processing section, etc. A modern rice mill as such is a much simpler when compared to wheat roller flour mill. Modern mill incorporates a rubber roll sheller along with the full combination of a paddy separator, efficient polisher, grader, sorter, etc. It's basically a rubber roll sheller mill. Many a times a disc sheller mill is incorporated along with these combinations. The extra yield obtained by processing in modern mills is at least 2% in case of raw paddy and about half to 1% in case of parboiled paddy as compared to disc sheller cone polisher mills. Head rice yields in the modern mills average about 5% more than those in sheller mills and 10 to 15% more than in Huller mills. Operations and equipments. Operations for milling of rice are as follows: cleaning or scalping. Cleaning is the first step in modern rice milling. It not only enables the production of clean rice but also protects the other milling machinery and increases milling capacity. Impurities that are higher than paddy are removed by an aspirator. This prevents spreading of dust inside the building and creates hygienic conditions. Metallic iron impurities are removed by the use of a magnet. Impurities larger or smaller in size but heavier than paddy are removed by sieves. Vibrating or rotating sieves or a combination of both are used. Impurities that have the same size as paddy but are heavier than paddy are removed by specific gravity separators, namely destoners. Paddy is often subjected to a preliminary partial cleaning, scalping, prior to storage and main cleaning in the mill. Dehusking or shelling. The object of dehusking is to remove the husk from the paddy with a minimum of damage to the brown layer and without breaking the brown rice grain. Husk separation. A mixture of dehusked rice or brown rice, unshelled paddy from the sheller is subjected to sieving cum aspiration to separate brokens and the husk. Sieving prior to aspiration helps in separating. Husk separator. The mixture of paddy, brown rice, broken and husk are fed at the top of vibrating sieve. The brokens pass through the perforations of the sieve. As the mixture of husk, paddy and the brown rice overflows from the sieve, the air is blown or sucked through the mixture. Husk is removed by the air. The paddy and brown rice are collected separately. Paddy separation. Shelling is never done to the level of 100% to avoid the rice breakage. The grains also differ in size so that the smaller grains remain unshelled. Therefore, a paddy separator is used to separate the remained unhusked paddy from husked brown rice. The separated paddy is returned to the dehusker for dehusking, while the brown rice is carried forward to the polisher. The separation is accomplished in the separator by taking advantage of the difference in the physical density, heaviness, size and surface smoothness or roughness of paddy and brown rice. Polishing. The brown rice is next polished to remove brown layers. Some amount of polishing is essential for easy cooking and storage, although excessive polishing reduces the nutritive value of the rice. There are two types of polishers, one of emery and other of metal. Emery polishers, also called whiteners, polish the grains by abrasion with emery, while the metal polishers, also called pearler, polish by friction between the rice grains. The emery polishers are again of two types, vertical cone polisher and horizontal. Grading. After polishing operation, the milled rice contains, in addition to whole grains, broken grains of different sizes as well as of some brown and dust. Separation of these materials is often termed grading. Brown and dust particles are removed by aspiration. Brokens may be separated either by a plant sifter or by a trier. Sorting is normally carried out through an optical sorting system. The optical system sorts discolored, D-shaped, and any broken rice left in head rice. The final product normally contains 99% head rice with uniform color and shape. Modern milling control technologies. Conventional controls. Conventional controls are generally single input, single output (SISO), proportional integral differential (PID) controllers. These have been in use for many years and are especially effective when process dynamics are reasonably constant. The objective is to adhere to some measurable set point. Other control systems have been developed subsequently to handle complex process dynamics. These include feed-forward control, which controls the feeding of paddy to minimize the disturbance of feeding. Ratio control, which helps in controlling one of the functions when the other functions can be varied. Cascade control. This is used to control the feeding of the partly processed paddy from one of the steps to another step of process. For example, from cleaning to dehusking, etc. Constraint control. These helps in moving a process variable to help in deconstraining the process if there are any constraints. Dead time or lagging compensated controls. These systems help in slowing the process, which helps in sampling and testing in between the milling process. This will help in uniform production. Automation and its role within the milling industry. A survey on the use of computer integrated manufacturing (CIM) and programmable automation (PA) in the milling and baking industries suggests that first, the milling and baking industries do not have CIM developments. Second, the number of such developments is slowly increasing, although slowly in rice milling when compared to wheat and maize milling. Third, industry, especially in India, remains unconvinced about the benefits of CIM and PA. Benefits of CIM and PA for the milling industries needs to be made more clear. The benefits of CIM includes quality improvement and improved production. Many CIM processes also have features that increase the hygiene of the process. In addition, it helps in product traceability and improves the process further based on rice varieties. These data are used by the millers to ensure optimum quality for customers, thereby increasing the profitability. Improving control saves energy and improves product consistency by making the system run in a uniform speed. Processes may also be operated closer to optimum values or constraints. In many cases, a simple control system will achieve the desired effect, but others require more sophisticated approach. This is true in paddy milling, as each variety is of different shape and size. Advanced techniques are required in a number of situations. In addition, simple controllers find it difficult to cope with the significant time delays between controller actions and system responses and non-linear responses from the process. Finally, advanced controllers are required where the process is expected to be flexible. Process control equipment methods may be divided into two principal subcategories, namely conventional controls and advanced controls. In addition to these major groups, controllers incorporating specialist features are also available. Robust control techniques add functionality to controllers that are designed to work under all operating conditions. These are applied especially in safety-critical applications. The type of controller employed in mills today fits into one or more of the above categories. It may be seen from the list above that many different types of conventional controller exist to cope with the most simple process requirements. However, the whole process control does not fit into this category of control requirement, and so advanced control techniques must be investigated in the future in order to increase the process efficiency. Dear students, let's conclude here. Rice being a major crop of the world is still a crop of Asian countries. Majority of the crop is used as cooked rice, and products are mainly produced from the cuts and bits produced during milling. Hence, during paddy milling, the main emphasis is the production of unbroken head rice or outturn. As paddy is mainly used in Asian population, the milling needs to be at the village limits. This has led to the development of rice milling systems ranging from the home scale to the large, complex modern rice processing installations. Large modern mills which produces uniform sized and colored rice are becoming popular. However, automation of rice milling is still not in use in our country. This was all about today's deliberation. Hope you have enjoyed the session. Thanks for your attention. Goodbye.